Okay, thank you so much for coming tonight. Today I will present to you one of the projects that I'm currently working on. So it's work in progress. I will start with a high-level kind of view and then get more technical in the end, so hopefully everybody gets something out of it. So let me just start by introducing my protagonists. So I'm pretty sure you all know Greta Thunberg, climate activist, known for school strikes, actually youngest Times person of the year ever. And you probably also know BERT, or you think so. He's a Muppet character, and I especially know him from the childhood TV series Sesame Street. But then, okay, now I have to, can I change the slides with this? No, just here. But then this happened. Google captured BERT and made him bidirectional encoder representations from transformers. It's a new way to turn words into vectors. Machines do need numbers to somehow handle words. And here I have some exemplary BERT vectors for BERT is the superstar. And the thing is, with BERT, Google found a new clever way to do this. So basically, BERT became an AI superstar overnight, improving Googling, improving machine translation, improving a lot of different tasks that all have to do with machines handling text. So maybe you could say that if BERT was a person, maybe he would have been Times Person of the Year. So the thing is, but what is so new about BERT? Because even before BERT, there were words, there were machines that somehow turned words into numbers and vectors. The thing is, I will focus on just two of the details here. As we have seen now, BERT actually has two meanings. So BERT could mean the Sesame Street character, or it could mean the neural network algorithm from Google. And what BERT itself, the program, does new, it starts with static vectors, and then it takes in information from the context to recalculate the vector that represents a word. And it does so, that's the second thing that made BERT a success, with a process called attention. And attention is a way to assign relevance to other words in the context that are relevant for the interpretation of the word. So I have here demonstrated this with the thickness of the arrows. So I would think that probably for interpreting BERT in this context, the word superstar is the most informative. But even though BERT revolutionized AI concerning with text, it is still a black box. So a whole research field has actually been founded around what BERT can do and what he cannot do. And there are still many cases where BERT fails, or BERT simply learns a shortcut instead of what the researchers want him to learn. So yeah, we're trying to get to know this guy. And so am I. And I was wondering, like, if he could help me to find some meaning, some insights from climate change discourse on social media. So now that you have gotten to know our protagonists, I will now go a little bit more into the research idea of this project. And the thing is, maybe you have heard of framing. I mean, we've heard of this last week. Let me just repeat a small definition. It's like a frame is an emphasis of certain aspects of a message that promotes a particular interpretation of a problem or also an actor. And you know, when we have a polarized discourse like around climate change, or especially around Greta Thunberg, there are many different ways she is portrayed. There are some who say that you should just go back to school, and others say, well, portray her basically as a hero. And I was wondering if BERT could pick up on those different portrayals of the same person by absorbing the meaning from the context. So I established this pipeline. On the left you can see what actually BERT does to text. It doesn't actually work with whole words, but it splits words into subwords. And I have masked the Greta token. I've done so because actually BERT was before Greta, at least before Greta became known and became a Twitter phenomenon. So it means BERT was trained on a lot and lots of text, but there were no mentions about Greta Thunberg at that point in time. So I masked the tokens so that now BERT will only integrate the information from the context. And it turns it into vectors. And what I did then is clustering. I sampled in total 50,000 unique tweets, and I clustered them with the k-means clustering algorithm. I did choose the number of clusters with a silhouette score. If you've never heard of it, it calculates the similarity of a data point to its own cluster as compared to the next best cluster. And that's how I chose the number of clusters. And basically, I mean, I'm doing this with Greta Thunberg, but basically you could just do this with any personality. The thing is, why it's so interesting here is because it's such a polarized discourse that we expect to find clusters. And in the end, and that's actually where I'm currently working on, there's probing classifiers to find out what actually divides the clusters. So before I now go into show you the clusters, let me quickly introduce Roberta. I actually did this clustering with a lot of different models, but I chose to present to you today BERT and Roberta. Roberta is similar to BERT, but was made by Facebook with a few minor technical differences, and mostly also it was trained with a lot more data. So let me show you the clusters. As expected, I can find clusters here, but the clusterability varies by model and it varies by layer. One interesting finding is that those are the principal components, the first two, that the range of the values of the principal components expands from layer 3 up until layer 9. Oh, this should be layer 6, layer 9, and layer 12. Sorry about that. Expands up until layer 9. This was true for all the other models that I tested. This is interesting, and in the end it gets squished again. This is interesting because the research has found that layer 9 is the best one for knowledge transfer. That could possibly be related to this. So, with these clusters, I mean, I did find some. The silhouette score indicated the number of clusters, and it also looks valid. But like we don't know like what makes these clusters. So What are you running the PC on? It's on the BERT representations. Yeah, for the masked Greta tokens in the tweets. So I built a probing classifier with a target the cluster assignment input the bag of words. So while BERT has a whole sentence structure and the different positions of the tokens as an input, this classifier only has, well, we have this word, and we have this word, and we have this word, but no information about the order. But this classifier nevertheless tries to assign the right cluster that BERT previously determined. So I built this one with different linear layers and ReLU activation function. Hidden size was 2048, and I used Atom optimization. And this network, oh, well, this is not helping. Where's my...
Probably the loss went down during 10.
Maybe it's a different PowerPoint version. I don't know. My pictures are gone.
BERT stolen, but Elmo stolen.
Anyway, the network was, I trained it for 10 epochs, and it was very able to completely overfit, and it started overfitting from the second epoch on. And yeah, I cannot show you the interesting details on that, but more relevant, and that I hope we can see. Yeah, you can see all that's necessary. Those are the classifier results. So we can see most of them are definitely better than chance. For chance, you of course have to think about K, the number of clusters here. And the colors, I made the different colors for the rows so that you can better compare those that have the same K. One thing that's striking is that BERT case uncased for layer 9 and layer 12 has a very high accuracy, but the problem is those were really one big cluster and one very small cluster, and as you can see with the macro F1, doesn't generalize so well to that one small cluster it had. I already implemented different weights for the different classes to account for class imbalance. However, I think in this case I would need more data for the small cluster so it can generalize, because these are the validation results, not the training accuracy. Anyway, it's always better than chance, but it does not, the bag of words model is not able to get really high numbers. So what I'm currently working on is I'm building a different model that, in comparison to this model, has no information about meaning at all, but actually gets only information about syntax, so that I can compare the results from these two classifiers. I will probably, or that's what I'm working on, but there are, of course, different ways to represent syntax. But what I'm currently doing is I'm using the part of speech tags and then add positional encoding, just like BERT has, so that a transformer layer can get the information about the syntax. But I cannot present this today, so we will have to wait and see what performs better. Thank you.